Thank you very much, and it's great to be here. I'm coming to you from New Jersey actually today, but you'll detect the Australian accent from my more youthful years than they are now. My kids sound like New Jersey, I sound like Australia, and I will say that right now Australia feels further away than ever. So it's nice to be on the call today, hearing those Aussie accents and thinking about family. What I was going to talk to you about today is data rainbows, and really. What this is, it's talking about a way to think about getting your cloud data to be able to use it more practically, more easily, more quickly. Now, what we do at Turbot is basically we watch over the cloud for various large enterprises and organizations. We provide governance. And what does that mean? That means really watching every configuration across AWS, Azure, GCP, with thousands of data sources. Our customers may well have thousands of Amazon accounts. They might have hundreds of Azure subscriptions all together. And then, of course, when you know those services, you'll know that each one of them actually has hundreds and hundreds of different APIs, schemas, and sets of data that are coming through. And because we're living in the cloud age, what's actually going on is that infrastructure is changing literally every second, scaling up, scaling down, provisioning servers, creating snapshots, volumes, etc. It is not exaggeration to say that you see pages of infrastructure change go past within seconds. It's moving that quickly. Now, what Turbot fundamentally does is it watches all of that configuration in real time and responds to it to make sure that you're staying safe and secure. So for example, if a user creates an S3 bucket and they make it public, within seconds, Turbot would detect that, set the tags on that bucket correctly, turn on protections to stop it being public, enable versioning, whatever your policies are. We have thousands and thousands of policies watching that environment and reacting to all of those events, etc., in real time, and querying that cloud constantly to make sure that the information is up to date. Because typically the events you receive from all the providers don't actually include all of the information. Now, in addition to all of that real-time change you have in the infrastructure, the other thing that's going on, of course, is that this cloud environment is moving so fast. The pace of change with new services, new sets of data, new controls, new security things we need to do is just really, really, really fast. So we can't sit on our laurels with our data the way it is. We can't curate a large set permanently. We have to be constantly thinking about how to move forward more quickly and more completely with that. So that's really the challenge we have, is working out how to capture all of that data from those different cloud providers, provide some sort of data warehouse, some sort of querying to that for ourselves to be able to react to that and manage that across time. Now, obviously that's hard and it's a huge amount of stuff. So then you start to ask, well, how am I going to manage this data more completely? Now you can pull in a big Andreessen Horowitz sort of diagram to understand the data landscape, think about all your different sources. What are you doing with your ETL, or if you're more modern, your ELT, to load that into your data lakes or your data warehouses to start querying it, running ML and all of those different things. And that's powerful. We absolutely have to do it. We all do it a lot of the time. But I think it's really important to ask yourself, what are we actually trying to do? What we're basically trying to do is run a query against some data. We're just sitting there, standing in front of our cloud and asking it to run a query. And it's easy to get lost in all of the engineering and collection of that information and get excited about the mechanics and lose sight of the goal, which is just to run some queries. And it turns out you can do a lot of those really quite simply. This is just a quick little demo flowing here of different queries we might run against our environment. Here we're running queries against, for example, your Amazon account to pull in information about your Lambda functions. Run queries against domain registrations. Are they available or not? Queries against your different Azure services, GCP. Anything you can think about in the cloud, we can start to just run SQL queries on. Now, there's a few things to note as this is going by. Am I worried about APIs for different services? Am I thinking about all the different libraries that I need to deal with to be able to work with that? No, what I'm doing is basically running through and just thinking about the SQL and discovering those things on the fly. We'd like to think of this lighter weight, simpler way of querying as light structured access to live data, or data rainbows, if you will. You know, we don't have any unicorns here. This is not that sort of thing. But really, what we're looking at here is structured data, you know, good organized information through SQL queries coming from the cloud. It's incredibly lightweight. There is no database to have to use or query, right? It's right there and live and available to us immediately. So we can work with that data very quickly and ongoing. Now, the way it works is basically using what are called virtual tables. Virtual tables is a technology that's been around for quite a while in different database engines. Two good examples are SQLite, which has virtual tables, and Postgres, which has foreign data wrappers, which provide a very, very similar capability. And basically what a virtual table is it's an object that presents that SQL table interface representing an external data source. Typically, they're used for cross-database connections, Postgres, talking to Oracle, other things like that. But they can also be extended for all this different API access. And two great examples, one is OS Query, actually. If you haven't heard of OS Query, it's very interesting. It's an open source project, came from Facebook, widely used now. And what it does is it provides a SQL-like interface to your operating system data. So you run SQL queries like select star from user, stuff like that from your local operating system. And then what I'm actually going to focus on a bit today is SteamPipe, which is an open source project that we've started at Turbot, which uses foreign data wrappers in Postgres to represent that cloud data. Now in the corner, you'll see this little thing called rose-colored glasses. And what I really want to just encourage you to think about there is, as you think about virtual tables, is the possibilities are really endless. You can put on your rose-colored glasses and look at almost anything: financial data, marketing data, cloud data. It doesn't matter. It's just getting represented through that SQL interface, and we can run with it from there. Now, beyond the virtual tables, what SteamPipe actually does as well is in that foreign data wrapper, it implements it in a gRPC or plugin type model. So basically, it's expanding out and letting us plug in all different services to that, so that we can easily extend our tables and our foreign data wrapper to other things. The way that works, users running a SQL query, this could be a user, it can be using a client, it can be using a pipeline, it doesn't matter. They're just talking to Postgres and running queries. And then Postgres tightly is integrated with that foreign data wrapper together. Our plugin then uses gRPC calls to talk to the different services, which then, of course, use whatever protocols appropriate for talking to Slack, GitHub, whatever it might be that tickles your fancy. So what I thought I might do is actually just run a few queries and let's see how that feels. So we can just run some simple queries here, like, for example, which users do we have in our Zoom account? That was live query against the Zoom API right there, 159 milliseconds, right, pulling in that user data. We can then run with that and do things like, hey, let's find all the meetings for that particular user ID. Again, live query, 64 milliseconds against the service. APIs are so fast now, you can do a lot of these things without worrying. Let's select all the different names of our S3 buckets from our account. So here we're just pulling in a set of S3 buckets, right? Live data, again, pulled in. Now, what's interesting about this and the way it's implemented to make sure it's fast and efficient for the APIs is there's a big difference between running select name versus select star. When I run this select star, it's actually going to go out and pull in all sorts of column data. And a lot of those columns are actually going to have to do separate sub API queries. So while there's 48 buckets, it's now going to go through and for each of the 48, do a whole sequence of sub queries. Let's see what happens. Running that, you can see it's taken 1 to 2.6 seconds, and it's gone through and pulled in all of these S3 buckets with all the different data across here. So a lot of these different fields, the logging, the versioning, et cetera, are actually different API calls that you have to make to get the different information from S3 about that bucket. So that did literally hundreds of API calls in real time there to pull in that information. And it's astoundingly fast. The next thing we can do when we're playing with these live queries is use that parallelism even more. In this case, what I'm going to do is run a query against CloudWatch log groups from AWS. This actually queried in parallel EU West 1 EU West 2, US East 1, US East 2. You could do all 16 regions, it doesn't matter. But basically what's happening there is it's automatically multiplexing those queries to get that information from all the different regions. It's not one API to call, there are multiples to pull that information in. Now we can really see that in action when we run a slightly bigger thing, like for example, IAM role. This pulls in more information. You may have just seen it start to stream there. We're at 85 rows right now, and it's still probably got a little bit to go, starting to get some throttling. And then it should pull in the final results in a moment. What's happening here is we're streaming through the results as they're available from the API without the back off. Thought that would finish, but I'm going to let that take a moment. Now, what I'm going to do is talk a bit about what's happening under the hood when we run those sorts of queries. It's a lot of API calls, it's a lot of action. What's actually going on when we do that to give us that magic of just calling APIs, but making it feel completely like SQL? The first thing is, what happens in Postgres when you do a foreign data wrapper query? It actually does about 7 different calls between the Postgres layer and the foreign data wrapper to make these decisions and work out what it's going to do. The first thing Postgres says is, hey, how big do you reckon this query is? So we typically say it's absolutely huge and you do not want to use me, right? Because almost everything else you do in the database would be faster than calling an API. The second question it says is, okay, if I'm going to ask you, what choices do I have? And we might say something like, well, you can scan me completely and that's expensive. Or if you give me this piece of information, I can give you the answer instantly or much, much more quickly. Postgres then comes and says, all right, I'd like to use decision X from those foreign paths. Can you give me a plan for that or get ready for that? So we get a notice that we've got to start preparing so we can then get our plan starting to be ready. What we're tracking through that is the method they want to use, et cetera, starting to capture that data down in the foreign data wrapper. It then says, I'm about to start, get ready. And then it says, iterate on your foreign scan. Basically, it says, give me a row. Can I have one row, please? Can I have another row, please? And it loops and loops and loops around there. That's actually the point at which we do the first API call. Once we're asked to give a row, we go off and ask for the rows in prep. We could do it earlier, but it might get canceled, so we're not sure. So we wait till that point. And then we start streaming the rows back as we get them from the service. Number 6, it could ask us to start again if it wants to, but more likely it just goes to number 7 and says, thank you very much. I have all my rows and I'm done and we can end this query. All of that happens in one select star from AWS S3 bucket, doing all that work, or in this case, select star from a Twitter. Now, what are we actually doing inside the API call? So just the part there where we're talking to Twitter, what's actually going on under the hood there to make this so fast and feel so interactive, right? The first thing that happens is when the query comes in, we actually multiplex by the source, like for example, a region. Very common in AWS when you're querying that sort of data source, less so with things like Twitter, et cetera. But when you're querying something like Amazon, you're like, hey, I want to collect information from multiple regions. I want to know what all my servers are, et cetera. So we multiplex out the query and actually start running it in parallel. That's some of the open source work we have there, giving you easy tools to do those sorts of things. The next thing that happens is it does the paging in order. So when we first got the query, we went and got 1 page of results. And then what happens is after that page comes back, we get a second page of results. Now, in this case, columns A and B are actually filled as part of the list query. Give me this information for the bucket. Okay, here's the name and the region. But then columns C and D actually require future API calls. We don't have that information from the listing API. This is very common when you work across different services, GitHub, AWS, et cetera, that different APIs will return you slightly different information. And you're trying to work out how to represent that as a single table. So in this case, what we'll do is we'll get the first page. And then as we have that page, we now get the second page. And meanwhile, while we're getting that second page, we're filling in the various cells from column C and D as well, going and doing sub API calls to get those other information, hydrating the columns, we call it. And then what happens is in the blue row, once we have all the column data for one row, we return it and start streaming it back. So now we go from having that much to another query, 1 more page, couple more things. We've streamed 3 rows. Again, more, whoops, on the yellow, we've hit a retry, we're getting throttled, okay, start backing off on that query. We have sort of tooling there to share the back off, to do things like limit how many connections we're doing in parallel, et cetera, inside the APIs, right? And so now what we're doing is we're returning the rows as they become available and bringing the whole thing together until the query is complete. And that's then how we get to such fast response through those queries. It's also why when you use a tool like this, when you query just, for example, the name, not select star, but just select name, what you get is an instant result, because it's just got to go page 1, page 2, page 3. It doesn't have to do all the sub-querying for the other column information. So that's what's going on behind the scenes when we run those queries. First of all, it's going through all the foreign data steps, and then it's filling in all of that data progressively and streaming it through. Now, what I thought I'd do is just step through some of the different types of queries that you can run with data rainbows and how they're a little bit different from your traditional database. We normally think of having all this data behind us that we're querying. But in this world, the data is like ephemeral. You can see it, but you can't touch it, just like a rainbow, right? It's structured and organized, but it comes from different perspectives depending on who's looking, right? So we have to think about our data a little differently to be effective. So the first thing that's interesting is just thinking about big data sets. So Twitter is a pretty big data set. Now, what we do instead of thinking and pulling it all in, we just run searches against it. So in this case, it's a table that's searching for recent tweets about the YOW conference. Oh, there I am. So Nathan Wallace is exploring the potential of data rainbows, which is great. So if you, luckily nobody's sending negative tweets about me. That would have been pretty awkward right now. But anyway, good to have that live data coming through. So you can think of tables as searching data, as opposed to sucking in all of the data and then querying it. Just search the source, and you can do a lot with that. Another good way to think about these big data sets is recent data. Things that happen just in the last day, the last week, whatever it is. Often that's mostly what we care about anyway. So we don't have to go crazy with everything. We can just query the recent ones. So for example, here's Hacker News articles talking about SQL that are just in the set of top results from recently trending articles at Hacker News. So searching for things, finding recent articles. We can do good things against our big data set that way. Now, what's interesting with that is we cannot ask Twitter to list all the tweets. First, they won't even give us an API for that. And second, if they did, we would be here forever, right? It's huge. But what we can do is we can get one tweet at a time. So you end up with these interesting tables on the big data set. I can't do select star from Twitter tweet because I have no way to list them all. But I can get one at a time. So that's Jack's first tweet that he sent a long time ago. And I guess it was maybe the 20th tweet because its ID is 20. Now, what's interesting is with this that large data sets as well, even if you're getting all of it, actually work remarkably well. Here we are pulling in all of the commit history for the GOTO project, which is an AWS API project written in Python. So it pulled in 3,500 commits from the GitHub API. In just 7 seconds, quickly got that information, right? And then that now is automatically cached in the tooling, in our case by SteamPipe, right, to allow us to do very fast caching. So, and we can now start to work on the query and play with it, and it's basically instant, right? Because we've already pulled in the data set to the cache, now we're just playing with it. Right, and we can run as many different queries as we'd like to work on that data and see how it goes. If I go back and run the first full query again, super fast because it's just sitting there coming out of memory. So big data actually works surprisingly well. You just have to think about it a little differently. What are you searching? What's recent? What's important to me? Can I just query that? Can I get individual items, sometimes with joins, etc., of course, right? And then actually be a little bit brave about what you query. You can literally get thousands and thousands of things in seconds without too much drama. It's not millions. I mean, we're not talking data lake, data warehouse scale, but in terms of recent, good, big queries, we can actually do a lot. The other thing that's really interesting about data rainbows is that they play with live data. It's not data that we've pulled into a stock, right? You can play with flows. Right, you can play with things that are now They don't have to be updated on a schedule. They're just now. So we can get the price of the most important different symbols that exist today instantly and all the time. And we didn't have to store any history or anything. We can just pull that information straight away. We can do things like get the history of it, get the information about a DNS record. So it's got an A record, a bunch of mail service, text records, etc., to start pulling in live data from the DNS service about what's going on with GitHub. Very quick, very easy to pull in live data. And often this is what we want. We don't actually want a large history stored. We just want to be able to get it straight away. And we can do all those things through the SQL interface. Now, historical data is interesting because it's similar. You can play with it as well and do good things with it. Here we are. We're going to pull in daily quotes for IBM for the last 10 years. By the way, that took less than 300 milliseconds to pull that from the Yahoo API. Incredible API, very, very fast for a large amount of data, 2,500 rows in 300 milliseconds. So we can actually do a lot here, right? So we can pull in that, and then we could also get, like, this should say hourly, my bad. You wouldn't do, GameStop on a daily basis. That would be too slow. So let's pull in our GameStop hourly data for the last 13 months. 1,900 rows, 240 milliseconds, and we're off to the races. Do you notice how the tables are designed a little bit differently? We build a daily table, we build an hourly table, we build tables that ask questions that we want to commonly use. Not unlike a data warehouse, what we're doing is trying to optimize some of these tables just to make the data very convenient to use, as opposed to sucking it all in and then querying it later. We have table designs that make it easy to sort of run with it. Now, the next and interesting property about data rainbows is that they're actually quite personal. They work with permissions natively. When we're thinking about a data warehouse or a data lake, we're sucking all this data in there, and then we're worried about who can see what. When we're talking APIs, what you can see is tied to your permissions. So we can start to run queries like, hey, let's pull from the GitHub organization. Now, of course, you actually can't do that because it requires us to pass a login, because there is no way to list all the public organizations from GitHub. It would be a ridiculous query in this case, so we don't do it. What we allow you to do, though, is specify a login to get one at a time. So you can pull in ones and twos. But now what you want, though, is you want to know what your organizations are. Right? You want to know what you have access to. So if I run mine, I see a series of different companies and different things I'm working on or part of, right, over time. These are personal tables, like my organization, my information, a bit different from all organizations, right? And we think about, by just redesigning some of the way we think about those tables, we can give the flexibility of getting any organization that exists, as well as getting my organizations and listing the ones that are relevant to me. So it can become quite important as you think about your data rainbows to break up your data a bit into things you want to get one at a time from a large universe of data, separate from the things that are yours, right? Where you'll get listing and other things according to the API. By the way, that's actually how GitHub's API works. They have a single API which will return you those different things, and it's based on permissions, right? So it's not uncommon for the API to really give you pretty good indications of how it should be used. Now, I thought I'd just share a few tips and tricks or fun things you can do beyond that. So in this case, what we do here is we're going to query the AWS IAM role. This is actually quite a big table by the time we do all the sub-queries, and in particular, the get policy query that it has to run for each role is quite slow, gets fairly heavily throttled. So in this case, what's going on is I'm just going to create a materialized view from that query. Okay, it took 7 seconds, not the end of the world. But what's cool is now I have an instant in my database 2 millisecond query that I can start to play with of all of that information. So we can use the power of the database with those materialized views, etc., to give us caching, abstraction, pulls from the data rainbows that we're querying live. Here's another more interesting one, which basically is going to go off, and it's querying AWS, GCP, and Alibaba Cloud simultaneously to get their buckets. And now I can run a multi-cloud, list all of my storage buckets across AWS, GCP, and Alibaba Cloud all at once. So that's a multi-cloud, single query, run instantly, pulled together from that materialized view very, very, very easily. Lets us start to build abstractions for storage, networking, all sorts of different things with time. Now, the final query I just wanted to show was basically a join. I mean, an obvious and good thing to do, but just give you an example of one. This is one within Amazon itself. In this case, we're listing the Lambda functions, and then we're combining them with the role that they use. By doing that, now we've got the function, we get the role. We can then keep building that query up. I'm not going to do it now because it gets big, but basically we're going to go from the Lambda function to the role, to the policy, to the permissions, and we can actually start to run a query that says, show me all the permissions granted to this specific Lambda function. So with the joining across services, right, the joining within services, we can actually start to pull all of our data together natively, which is so much easier, right, than having to do complex scripting, combinations of data, all that sort of thing. We can use the power of SQL to do that work for us, and it runs instantly. So the next thing I wanted to just talk about was just sort of wrap that up a bit with, when should you think about using these data rainbows, right? I mean, these are not data lakes and they're not data warehouses. You need those tools. They give you huge and great access to big data for all of the analysis, all that sort of stuff you want to do. This is not appropriate and does not replace those. But what it does do is it gives you a lot of flexibility at the edge, and it's an important thing to think about that could really be a powerful tool in your toolbox to make you move faster and give you more flexibility with your data. So some of the good indications that a data rainbow is a thing to think about is if your data moves a lot, changes quickly, just query it live. Why spend a huge amount of time pulling it in, sucking it in, if you can just query it live? Right. So fast moving data is expensive and hard to maintain and keep a copy of, so instead run live. If you're in exploration mode for your data warehouse, right, query it live, play with the tables. Some of them might take seconds to run, but you're learning and you can work on your personal data set and work out how you want those to look, how you want those joins to play before you really lock it into a larger recurring design with your ELT tooling. Smaller teams should definitely think about this. You just don't have that much data. It's surprising how much you can get away with in this model. We've been shocked at how well the live worked. In fact, we were initially planning to do a lot more, more pulling the data in and using materialized views. And we just found the live just works so well for reasonably large data sets that if you're a smaller team, you should just go for it. It really does work surprisingly well. If your data is personal and permissioned for you, data rainbows are great because they're tied to your permissions. You don't have to worry about any of the abstraction of a whole new permission system and all that stuff. It makes all of that melt away. Often when you're thinking about your data, you're like, I'll suck it all in and then I'll query it. Is a search query enough? Can you just search Twitter for YOW data and get what you need? Right? If so, data rainbows are a good fit. Let the service do the searching for you. Let the service do the querying for you and just enjoy the results. It's so much lighter. There is no database. I'm not running a database. I have an embedded Postgres right now, but I'm not running a separate service. It's just running in the CLI. It's so lightweight. If your queries are really thinking more about recent things, again, lighter weight, you don't need all that data. And a lot of that really just comes down to, is the cost of your extract and load and transform high relative to the value or use of the data? If it is, data rainbows are really, really powerful. The final point is enrichment. Live data queries enriching your stock. Think about data rainbows for your flow. Think about data rainbows for the extra stuff you want that's coming from around your main pieces of data. Use your data warehouse or your lake for the big stuff and use this much lighter model around the edges because it's just SQL. And that's everything I wanted to cover today. So happy to take any questions. Thanks so much for your time. If you want to learn more about it, the links are there. I spoke about SteamPipe today. There are other approaches, of course, but SteamPipe's completely open source. We'd love your input. We'd love your involvement. And of course, hit me up on Twitter. I'm happy to answer any questions as well. And I'll be in the Slack channel, of course, after this. Thank you.